Lambert is the head of the Open Science Lab at the Leibniz Informationszentrum Technik und Naturwissenschaften, and is generally involved in many different activities involving open science. And the topic for today is data ethics and open science, navigating the complexities of research data accessibility and transparency.
2013, there is not such a thing as a standard model of scientific inquiry. I just made this up, but maybe you allow me to try to keep it very simple. So the typical classical way of doing this business is having a research question. There are certain criteria for this, so should be very specific, feasible, relevant. And after that, you collect somehow data, right? So you do a survey, you run your experiment in your lab, you do the required work of analyzing, and then you have a result. And this is like interpreting, discussing your data. And the intention is here that this is your inquiry's main outcome. Once you decide to open your data, you can somehow change the order of these steps. So you might start with some data that is already out there. You can use it as long as it is well enough documented. So as long as you really know what this data is about, raw data in itself is useless. So there's a question immediately coming up. Whose data is it? So in the traditional order of things, once you come up with your data, it's yours. So like one brick in your own research results. And now this changes because maybe somebody else came up with some research data and you can work on it. And starting from there, and this is maybe the decisive point, you can be original and new and surprising with the kind of question you want to answer with the research data already given. And this is like the starting point of what we also call team science. So it changes the social order of research. It turns out that things like the Nobel Prize, okay, it's already out there, but it's kind of an outdated concept, right? If you look at typical example, here's a Large Hadron Collider or so, where you have papers which are authored by like hundreds of researchers. You have the means of contributing to data that is already out there, either to enhance the data, annotate it better, or do something with the results. And this creates some post-heroic thing where not the individual contribution is that important, but it creates a condition of team science. Potentially, you can have many, many co-researchers, or it can be even community science. So in former times, we also talked about citizen science. I think this is an outdated concept because this is not about the status of citizenship, but actively involving people who are not from inside academia, essentially. And then again, you have the usual things with your research results, interpreting, discussing, allowing others to be skeptic about your results. This is still the same as in earlier times, of course, but you can have so many more research outcomes potentially. Now, what are the pitfalls of opening the data or not opening the data, you might ask, right? But once you decide to open up your research data, this gives also the opportunity to misuse your data. Others can pick from your data something and come up with a hypothesis that might fit your data retrospectively, or just by looking at correlations in your data with some other data and making things up. So this is possible. Or they can just misinterpret what your research data is really about. And there are many other ways to misuse research data that is available in the open. You are aware of that. And the whole field is aware of this. If you have a look at the publication in the top right corner of the slide, there's a whole catalog of how to misuse data. And of course, everywhere where research data is in use, this has already become part of the curriculum. If you have a look at data science courses, you will somehow find this covered. It turns out this is a well-known problem. So besides the potentials of opening up research data, that there's this problem or this risk, and still, we have all these problems. So many, many research papers on a regular basis are being retracted because of misuse of research data. So when it is already a well-known problem, but it still happens so often, there must be some different problem. And our problem today is not that we do not know enough about good practice in terms of research data, but that research is wrongly incentivized. So we have this hierarchy of journal brands. We have artificial systems of artificial competition, which of course somehow fit this concept of journal brands. And it's not just missing data literacy, because this is already being addressed, but there's something in the system, what's going wrong here. So we need to safeguard the relationship between data and results. This is like one of the huge challenges in the field, of course. And in the end, it shows that safeguarding the relationship between data and results means being open about your data as much as possible, to allow others to make the connection between your results or somebody else's results and the data. And this is just science done right, right? So this is applied skepticism about results. This is nothing more than this at the core. So much for some preliminary basic concepts. Now let's dive deeper into the history. So peeling the onion's layer, so to say. This book, it's really interesting. It's from 2008, and Michael Nielsen makes some observations about data science, which are still valid today. What he states is that the way we do scientific inquiry really is changed by the digital means which we have today. He points out as an example, for instance, to a platform for astronomy data called SDSS. It's still alive. Have a look there. And he portrays some more examples. And if you look from what we know today on these examples, you will easily discover, first, he talks about open data all of the time. We hardly do that anymore, right? For a reason. I will come to this, but it's interesting. It's almost like a trademark of that time. So as an analogy to open source, there was this very valid, very interesting thought that data should be in the open in general. So people of that time talked about open data a lot. But at the same time, as Michael Nielsen's examples also show, that open data is a huge extra additional effort in addition to what researchers usually do. The projects he talks about are usually some by large institutions because of this extra effort. And it turns out that these are almost always like tailored one-time platforms. So you have a certain kind of data and you have to come up with some platform to host it, to allow others to discover it, to do something with it. But it's like a very specific way. Most likely in these times was like looking with Google or some other web search engine about data from your field, or having heard about this somewhere. There was no really systematic findability of research data in any way. Many people discussed technical aspects like storage. This was the time before the hyperscalers, where you could easily rent some Amazon Web Service space, and just by financial means, you can just outsource all of the technical things to somebody else today, which are related to hosting, making accessible data, also the compute, like doing computation on your data and so on. But at the same time, we already discussed these higher level problems of the need for norms about research data. One very important, still very interesting example of this is Tim Berners-Lee TED Talk in 2009, where he demands linked data. So he invited his audience together to say, this all happens against the backdrop of a huge, huge change in open access, which is, of course, a closely related field. So until this point in time, open access felt like a grassroots movement, something revolutionary against commercial publisher models. And once of a sudden, it turns out, no, open access can be incorporated by traditional publishers as well. So this is the acquisition of Biomed Central Springer back then. And also against the backdrop, if you see the larger picture, of an unprecedented empowerment of end users of any kind of data and computation. So since that time, we all have these small supercomputers in our pockets. And it happens, of course, against the backdrop of a huge change in trust in large institutions, because we had the times of the failing of the global financial system back then. This comes all together, culminating in this call for open data, maybe also the idea of shared responsibility and empowerment of the individual user. And then we have, so at least from the German perspective, a very interesting step in between, the EHEC outbreak. From my perspective, this was the first time that things like research data were discussed in a broader audience in the German public. So there was this famous Bild-Zeitung title, but also other media covered this. And it turns out that at this time, abruptly, the way research data was being worked with changed a lot. Let me quickly explain the EHEC outbreak. There was a virus outbreak in Germany. A few people really died from that. And in the summer of 2011, everyone was wondering where this virus came from. There were some labs doing a genome analysis of traces which they found, and they were discussing these results very much in the open. And these were a few very interesting weeks. Because the interesting thing is the researchers did not wait to use some preprint server with proper papers or so, but instead they used their blogs and early Twitter to make themselves aware of what they just found out in their lab. And some researchers just uploaded their data to GitHub. So today, this is not a surprise at all. But at this time, that was interesting because these are consumer web platforms, right? Okay, GitHub is not exactly a consumer web platform, but it was kind of misusing the platform for something that it was not intended for. So far, GitHub was only like for open source software code repositories. But this kind of organic growth of lab competition and collaboration at the same time, this was allowed by digital platforms, which were originally not intended as research platforms. And this is super interesting, and we can still learn something from it today, because it shows that researchers just make use of what is out there and what is practical, and do not necessarily always wait for some tailored thingy that's just specifically made for them. And in a way, all of these practices that I describe here are, of course, all there and have been established as normal as well. So a few years later, we see something like big commercial companies, for instance, Springer, but not only Springer, all of the former science publishers adapting these increasingly digital workflows. So from analysis to data storage, making data available, discuss the data, and even preparing papers. The whole circle of doing research happens in the digital realm, and these big commercial companies respond to this by trying to own the full digital research cycle. It was at this point very much in time an observation from Bianca Kramer and Jeroen Boosman at this Utrecht University Library in the Netherlands. They came up with this beautiful website that is already out there, 101 Innovations in Scholarly Communication. These are commercial entities, and they look for new business models. They have to because of shareholders and so on. And it turns out that the huge model of, for instance, social media today, they try to make it feasible for researchers as well. So they open up these neatly integrated workflows where your data is being collected by them, which can be made profit of. And platformization is something that is not unseen. Responding to things like this, we have the GDPR from the European Union or similar, for instance, California and the US. And you have companies like Elsevier very much in the open stating that they are not a publisher anymore, but they are a global information analytics business, which is their word for we collect all the data we can get of what researchers do on our platforms, and we sell it to many, many other countries for a profit. You can already tell the advancement of this by the fact that GitHub sold itself to Microsoft for billions, literally, around that time. This was quite an interesting moment. Only very few years ago, Microsoft tried to battle open source approaches with hand and feet. but stance changed a lot because this working with data in the open on large platforms became the new normal by them, not only in research and open source software, but there as well. And you might wonder, what is really exactly the business case? Why collecting data from researchers' activity? How is this viable as a business? Just have a look at this wonderful film, The Social Network by Aaron Sorkin, where there's one scene where one early colleague of Mark Zuckerberg tells him, oh, we should start to sell ads. And Mark Zuckerberg says, no, we shouldn't, because this is like, so these are my words now, we speculate on future profit. So this is what these new business models are about. This is not actually advertisement that you are being shown in your browser, but it's like a speculative business about your activities, which are recorded all of the time and sold to many companies. And even if they are not sold yet, it's signaling to your shareholders from a company perspective that you have these valuable data about the specific audience researchers. There are many things culminating at this point in time. We have the FAIR principles. I think I don't need to introduce them. There was an interview from Nature Index with me. At that time, I coined it like it's a love letter to your future self to do good research data practice. Because the thing is, the first user of your research data is maybe you. So if you think about it, research data that you work with, let's say 10 years ago, will you still find it? Do you know on which hard disk this is or on which USB stick? Probably not. But if you back in that time did something about the findability, about your own research data, you will be able to find it now, for instance, in some special research data repository or so. And also from that time, it became like official policies. This is not just informal good practices somewhere by someone, but large funding agencies like DFG created their Leitlinien. And then it was still a few years later that we also came up with good practices and policies about taking care of sensible data, which do not only come up in medical research, but also in the digital humanities, virtually in any field. And we have this interesting thing of maybe also slightly conflicting goals. So while fair data is not open data anymore, findability is something other than openness, talking about giving minorities agency about the way research data about them and their cultural artifacts is still something very different. It's not like a contradiction to make to the concepts, to applying the concepts of making data findable, but it's one additional consideration to make. And of course, we have to see the coming up with the care data principles against the backdrop of the fair data principles itself, but also the platformization, where we have the question of who literally owns the data, somehow luring in the background. And we also, of course, have the backdrop of the climate justice movement, which also, in a very similar way, but on a political level, asks these questions about global equality and agency. As a thought experiment, think about it. Who are really the stakeholders of your research data? And are you actually talking with these researchers? Is there some way that you can expect how they learn about your research data? To learn about the fact that there's research data they are somehow related to out there. Our approach here at TIB is mostly about taking care for data in a way that makes it inviting to look at the data level and to allow researchers to involve people actively and to track continuously in a transparent manner what is being done with the data. 5 years ago, when we co-wrote the NFDI for Culture original proposal, we set our bet fully on Wikidata. So our idea was we need to have platforms that are already out there where we have a broad consensus, many users, people taking care of the platform and evolving a whole software ecosystem around that. And at that time, we were so sure that for many, 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 many things we do, especially in a digital humanities field like culture, heritage, can be done in a very meaningful way on Wikidata. But as a trade-off, so to say, with fair data, we decided to work mostly with Wikibase, the software behind Wikidata. So to make sure that data is in a way very easily transferable to the Wikidata universe, but at the same time, it's stored in a safe place. And we have the full agency of researcher communities and communities who are affected by the data. To give you one example, there's a Wikibase instance in the servers of TIB running on endangered cultural heritage in Ukraine, where we collaborated with photographers and cultural heritage experts on the ground in Ukraine. And we have this Wikibase instance where we make sure that we have very actual good information about, for instance, old churches which are in danger with their precise geolocation data. But we do not want to present this to the public because this is a potential target in the war. No way of putting this on Wikidata. To give you one example, or more recently, there was even a short report about this in NDR Fernsehen. We helped the Archive, a huge platform for physics and other sciences in the USA, to safeguard their data. So to have the full data from Archive at our place, just to make sure that it is not harmed by the Trump government. The interesting thing about knowledge graph, it's a basic ingredient of artificial intelligence. You will hardly have artificial intelligence without it. Large language models work that way. Just unstructured, you can have a huge body of unstructured text, which you put into your large language model. This works too in a way, but the results will be better and the reproducibility is better once you have a structure in your knowledge before you apply it to your large language model. So if you have a vector database, which feeds into your large language model, make sure you have as an intermediary step knowledge graphs like you have in Wikidata. And the AI will help you to create these knowledge graphs. But this, let's say, preparation step is a huge thing. One example of such a fine-tuned large language model, which is trained on the basis of 8 million research paper, is here at TIB, our ORKG Ask. If you haven't done it yet, try it. It's based on this open source large language foundational model Mistral from France. And otherwise, I can only say don't wait at any point for institutions and businesses. Instead, go out playing, especially this new way of working with data, which is involved with knowledge graphs, large language models, generative AI, and so on. This is something that you should really have your hands on all of the time to be able to have a deeper understanding and to discuss these issues. We have never experienced a time where all of these things are moving that fast, right?